All right, so last time you've now done a few where you've translated statements. Now we can use these statements. There's two different ways we can use these. We can take these symbolizations and we can actually use what we call natural deduction. But before we do that, we always use it to find what we call a truth function. And truth functions can help us compare statements, help us classify statements, and they can also help us determine validity in an argument. Now, how does that work? Well, the idea here is if you have a statement like A, Alice is tall. Alice is tall is either true or false, right? And so it's true, it's false. I don't know. You can determine that later. That's kind of independent of how an argument works. So if you have an argument like A horseshoe B, A therefore B, this is what we call a modus ponens, which we'll talk about later. This can be determined to be a logically sound or valid form, but that doesn't make this a true argument, because if A is false, if this is false, then this argument isn't actually proving this, right? There's the factual claim, and there's also the value claim, right? And so what happens is those are two things to keep in mind. Now, with that said, is what you can do though is if you know if A is true or you know if B is true, then you can also know if A and B is true. And the reason is if A is true and B is true, then you know A and B together is true. Because if I say Al is here and Bob is here, and that's my statement, Al and Bob are here, and it's true that Al is here and it's true that Bob is here, then it's true combined that that's true. So let's just start off with tilde. Let's suppose you have like the letter A, and then over here you have the letter tilde A. We know that if A is true, then we know that not A is false. And we know if A is false, then we know that not A is true. We know that whenever A is true, not A is false. Whenever A is false, not A is true. And so we can kind of learn that relationship exists, so that whenever we see an A and then we see a tilde in front of it, we know that A is true, that makes this false. We can actually determine the truth function. And what we do this is we can find, when we put things together, we find what is called a truth function. A truth function is the idea that the truth is a function. It's something that comes out of the statement. That when you have a longer statement like A horseshoe B dot C, that if you know that this is true and this is false and this is true, you know that you can determine whether or not this statement in and of itself is true or false. And we'll talk about that here in a minute. But the first thing you need to do is to learn these relationships, that when A is true, or when something is true, the tilde becomes false. When it's false, the tilde becomes false. So we then come back to like something like P and Q. So we have letters P, Q, and then P dot Q, so the combination. And we know that P could be true and Q could be true. We know P could be true and Q could be false. We know P could be false and Q could be true. And we know P and Q could both be false. Well, if P is true and Q is true, so Paul is here and Quentin is here, and both of those parts are true, then it will be true as a combination. But if I say Paul and Quentin are here, but you know Quentin's not here, then I'm lying when I say Paul and Quentin are here, because you know he's not. It's false that Quentin's here. So the whole statement is false. And Paul not being here makes it false that Paul and Quentin is here. And if they're both not here, it's definitely false that they're both here. So the only time when you have a dot that it will be true is if both of the conjuncts, both the parts before and after the dot, are true. Otherwise, it's false. A conjunction demands both parts be true. Now, on the other hand, if you were to change this from a dot to a wedge, we know that if P and Q are true, well, then P or Q is true. Yeah, if I say Paul or Quentin is here, you know Paul is here, you know Quentin is here, you know it's true that Paul or Quentin is here because they're both here, right? And it's not saying one has to be here and the other not. It's saying, Paul or Quentin is here, both can be true, and it's still true, a statement. But if Paul or Quentin is here and Paul is here, it's true. If Paul or Quentin is here and Quentin is here, it's true. The only time it's false is if both of them aren't here. Because then if I say Paul or Quentin is here, and you know neither of them is here, then you know that's a false statement. Now, the next one is, let me find this. If we switch from that over to horseshoe. And so if I say if P, then Q. Well, what we're doing here is we're saying if P is true, then Q has to be true. So if P is true, then Q has to be true is true. However, if P is true, then Q has to be true, but P is true and Q is false, then this is a false statement. Why? Because if P is true, Q has to be true. It can't not be true. So you know that that is a false statement. When you combine that and you have a time, if it's ever possible that P is true and Q is false, then the combination, the idea of if P then Q, doesn't hold up as an idea. If it's possible that if I come to the party, then everybody will be happy, and I'm at the party and not everybody's happy, then it's false, the statement that if I come to the party, then everybody's happy. It may be true that I'm there. It may be false that everybody's happy, but it's definitely false that if I'm there, then everybody's happy. Now, if on the other hand, you have a statement like P then Q, and you have P horseshoe Q, what if it's false that like, if I'm at the party, then everybody's happy? And it's true that everybody's happy, but it's false that that I am there. Does this make the statement, if I am at the party, then everybody will be happy? Well, we know everybody's happy at the party, but I'm not there. But we don't know that if I'm at the party, then everybody will be happy wouldn't occur. It might be the case that it's true that everybody's happy because of something else. Maybe it's because my twin brother, Shim, instead of Tim, Shim is there. And Shim is also a delight and he makes everybody happy, just like me. And so everybody's happy because of that. But if I was there, it would also happen. It's just like saying, if you committed this crime, then you'll go to jail. You didn't commit the crime, but you get into jail. Well, it's still true that if you committed that crime, then you would go to jail. But it may be the case you got caught on another crime, and that's why you're in jail. So it's false you committed this crime, but it's true that you committed the other crime and are in jail. So the fact that that conditional relationship exists can still exist even if the antecedent is true, false, and the consequent is true. It really is only proven false if the antecedent is true and the consequence false. The only time you will have the only way you can prove that P horseshoe Q is false is if you have a true antecedent and a false consequent. A false antecedent but a true consequent doesn't negate this relationship. It just means the consequence is true and the antecedent is false. I mean, that doesn't necessarily happen. If you do this, this will happen. Well, if you stay out past curfew, then your parents will ground you. That's true. But does that mean that if you didn't stay out past curfew, then your parents wouldn't ground you? Well, they could ground you for other reasons. It's still true that if you stay out past curfew, then you will be grounded, right? But it also might be the case that if you get caught drinking, then you will be grounded or something like that. Or if you, something bad kids do, call your mom a name, then you'll be grounded, right? So just because it's false that you stayed out past curfew, but it's true that you're grounded, doesn't mean that this statement is false. This statement may still very well be true. But it just may not be the case that you're grounded because of the reason in this case. This is sufficient to cause your grounding, but it's not necessarily what causes you grounding. That's not the only reason you can be grounded. And so this can still be a true statement even while this is false. And so same thing here. Suppose you're not grounded and suppose you didn't get caught drinking or whatever. Well, that doesn't mean that wouldn't be true, that if you were drinking, then you'll be grounded. That may very well be true that will happen, but the fact that you didn't do either doesn't suddenly make that a not true statement. For example, if you don't do any work in this class, you will fail, right? Now, that's a true statement, whether or not, and maybe you do work and maybe you don't fail. And so both those parts, the antecedent and the consequent, are false, but it doesn't make the conditional situation true. So the only time it's it's false is if the antecedent is true and the consequent is false. Now, we can come back here and we can go P and then Q and then P triple bar Q. Well, as I said, P triple bar Q is just simply a combination of the biconditionals. It really is like saying P horseshoe Q dot Q horseshoe P. And it's saying both. And so what happens is you know essentially that P horseshoe Q is only going to be false if this one's true and this one's false. And this one is true or this one is false. So if they do not match, if P and Q don't match, if they're both true, P horseshoe, true horseshoe true is true, and true horseshoe or false horseshoe false also gives you a true. The only time it's not is if these two don't match, if their truth values don't match. So with triple bar, it's false when one's, if it's possible for one to be true and the other one false, that biconditional relationship doesn't work. The biconditional relationship does work if the truth flat value of each part is true or false, if they match. So if they match, it's true, and if they don't match, it's false. Now, with all that said, you can kind of follow through and think about what each of these means, and that's a great way to do it. But the other thing is if you want to be any good at doing all this, what you really need to do is you need to just write down a piece of paper that looks kind of like this. Looks like this. And then P, Q, P, triple bar, Q. And you just do this, and this, and this, and this, and this, and this. And then you come in here and you write out all the possible truth values. And you go, you know, true, false, 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 P wedge, you know, true, true, false, false, true, false, true, false. You know, you have to write a lot neater than that. And you know, true, 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 false. And then with horseshoe, it's true. The only time it's false is if this one's true and this one's false. So the others are true. And this one, it's true, false, false, true. And this one is true, false, and false, true, like that. If you can do that and you can reproduce that without looking back at your notes, you're going to be a lot quicker at doing truth tables. So I would highly recommend that you do that. I'm going to go ahead and stop this for now, and I'll come back and do another video kind of to finish out this week.